Okay, greetings to all. I am Dr. M. Shakti Mohan, Associate Professor. In today's video, we are going to discuss about the combinational circuit design, in particular with BCD order design. So we are going to discuss about each and every details regarding the BCD addition. That is, what is BCD, and from which digit to which digit BCD will be there, and the valid BCD addition and invalid BCD addition, and how to convert the invalid BCD added result to valid BCD order. So we are going to discuss one by one. So we'll enter into the video content. Okay. So before entering to the BCD addition, first of all, we must know the basic things related to BCD. So generally, what is BCD means? Actually, the expansion of BCD is binary coded decimal. That is what the expansion of BCD. That is a binary coded decimal. That is what the expansion of BCD, right? Okay. So like binary, actually binary having the digits from 0 to, if it is a 4-bit now, if it is 4-bit now, the binary having the digits from 0 to 15, right? So likewise, in BCD, if it is 4-bit now, it having the digit from 0 to 9. So that means from 0 to 9, it is called as a valid BCD number. Okay, if it exceeds 9 now, okay, so that is, if it is greater than 9 means it is called as a invalid BCD number. Okay, it is called as a invalid BCD number. Okay, that is the case. Okay, so we'll see one by one. Okay, so before entering into this, first we'll discuss about some basic addition. Okay, that is BCD addition having two kind of operation. The result is less than or equal to 9 now, so we are going to follow one procedure, and if the result greater than 9 means we are going to follow some additional procedure. Okay, so first we'll discuss about the result below 9. Okay, so below 9 means, for example, 0101 0011. Okay, so if you make the addition now, what is this? Actually, this is 5 and this is 3, right? So 5 plus 3 is equal to 8. So we'll see one by one. Okay, so 1 plus 1 is equal to 0, and again 1 will be there, and 1 plus 1 is equal to again 0, again 1 will be there, 1 plus 1 is equal to 0, and this one will be here, and 1. So now you can see this is 8. Okay, so 5 plus 3 is equal to 8. Okay, 8 4 room concept. So this is what the 8. So this result is less than 9. So less than 9 now, it is called as a valid BCD number. Okay, valid BCD addition. Okay, so the next example we are going to discuss 10100101. Okay, so just to make an addition, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1. So this is 15, right? So that is, this is 10 and this is 5. So 10 plus 5 is equal to 15. Actually, if it is greater than 9 means it is called as a invalid BCD number, right? So it is called as an invalid BCD number. So to become this invalid BCD number to valid BCD number, so we have to do one thing, that is we have to add binary of 6 with the result. Actually, binary of 6 is the correction factor by the BCD addition. So that means the actual result we got is 4 1. Okay, so the binary of 6 is 0 1 1 0. Okay, if you make addition now, very simple, 1 plus 0 is equal to 1, and 1 plus 1 is equal to 0 here, again 1 will be here, so 1 plus 1 plus 1 is equal to 11, and 1 will be here, and again 1 will be here, so 1 plus 1 is equal to 10, and 0, and the carry will be 1. Okay, so this is what the valid BCD number now. Okay, so actually it is very very simple. If you include 3 zeros in front of this one na, you know that any number in front of 0, if you add it na, no need to worry, right? So 0, if you add it 0 na, so that is what the BCD number. It is very simple. The simplified method is, if it is 15 na, you have to write binary code for 1 separately and 5 separately. That is valid BCD number. Very simple. You can see now, this is for the binary number of 1 and this is for the binary number of 5. That is what. Okay, in case 0 to 9 na, we are going to write the binary value as it is. After 9 na, for 1 you have to write separate binary code, and 0 you have to write separate binary code. That is what BCD addition. Okay, so now we'll move into the content page. Okay, So the theoretical part, a BCD adder is a circuit that adds two BCD digits and produces a sum digit also in the BCD. Right? So BCD number uses 10 digits, since I already told you that 0 to 9 will be there. 0 to 9 will be there in the BCD. Right? So in the representation and all very simple. 5 na 0 0 1 1, 0 1 0 1, and 2 na 0 0 1 0, and 6 na 0 1 1 0. Right? So you can see sum equals 9 or less than with carry 0 na. So this procedure will be followed. That is just now we have discussed. As it is, you have to take the result. Okay, if the result is exceeds 9 na, for that you have to make a correction factor. That is, you can see here 14 is the invalid BCD number. So for that you have to make an addition with a binary of 6, that is 0 1 1 0. Right? So this is how we have to make the binary addition. And this is what the truth table for the BCD adder. Very simple. So the truth table contains, that is the output contains 0 up to 0 to 9, it contains 0. And after 9, it contains 1. That is what the truth table of BCD adder. Sir, why up to 0 it contains 0 and after 9 it contains 1 na? Because you know that up to 0 we will write the number as it is. For example, 0 0 0 2, 9 1 0 0 1. Okay, so after 9, if it is 10 na, how we will write 0 0 0 0 for 0 and 1 1. And for 11 1 and 0 0 0 1. Okay, likewise we will write no. So that is what the process. Okay, so this one will be the carry like it. Okay, so that is why in the BCD order truth table up to 9 the output will be 0. Okay, after 9 the output will be 1. Okay, for this we'll put for this we'll put the K map, and once you simplify the K map now you can get the result of, that is y is equal to S3 S2 plus S3 S1. Okay, for this you have to make a logic diagram, but here the logic diagram is somewhat different. I'll explain it, so don't worry for that. Okay, you can see in the BCD order we are going to use two 4-bit binary order. So the first binary order, what it will do now, so the A bit B bit it will make the addition. Okay, so there will be a carry in and carry out. If the result is less than 9 now, straightly it will produce the result here. Okay, if the result is exceeds 9 now, there will be a correction factor. So that is what here you can see 0 1 1 0. Actually the correction factor for the BCD addition is binary of 6. Okay, so that means if the result is exceeds 9 now, so those greater than 9 result will be here and the correction factor will be here. Again this 2 will be added with the help of 4-bit adder and the final result will be delivered here. That is what the logic diagram of BCD adder. I hope you can understand the today's content. Today we have discussed about the basics of BCD, that is binary coded decimal, the valid BCD addition and invalid BCD addition. If it is less than or equal to 9 now, if it is called valid BCD addition, and if it is greater than means it is called as an invalid BCD addition. So for invalid BCD addition to become as a valid BCD number, so we'll go for the binary of 6 addition, that is correction factor, and for that we'll design the truth table and then logic diagram also there, right? I hope you understand. Thank you.